Hi again. Okay, so this one goes with your second handout. Okay, it's just double-sided, so we'll fill it out together and I'll have some examples for you to do as well. All right, so the first thing is we want to kind of talk about what I is and what we use it for. Okay, so first thing that I have this little asterisk here for is that I is used to help us with when you have a negative under a square root. So it's used to help us simplify. I don't know if I can fit this in, I'm writing too big. When you have a negative under a radical. Okay, so the definition of I is really defined, the I is really defined to be, okay, it's an imaginary number that's defined to be the square root of -1. Okay, so the one thing I want you to remember here is every time you see an I, we know I is an imaginary number. I know that sounds kind of silly, that's kind of made up, but it's really just a whole other side to the number system. You have kind of real number, the real number system, which you're used to working with, and then you have this imaginary number system. Okay, so I came from this, it's defined to be the square root of -1. So if you kind of just think about just the definition of that, you can make a guess as to what the definition of I squared would be. And if you just square both sides of the definition of I, you can see that I squared would be -1. Okay, so hopefully that's a little bit interesting to you, the fact that this is a real number, this second power, whereas the first power was an imaginary number. Okay, and that happens every other power of I. This power of I on the right, I'll go through with you really quickly next class. It's really just something I do as an extra. It's not required, but I usually give a little bonus question and kind of show you how the other powers of I work, like I the third, I the fourth, and how it rotates. Right now, all we're going to worry about is I and I squared. All right, so how do we use it? We use it to really simplify things we had to leave blank before. Okay, so let me just write down a couple examples here and show you what we'll do with them. Things that we would have just said before, oh, that's not real. So we already know how to simplify radicals, okay? So if we can simplify radicals, this is really not much harder, okay? So if I have the square root of -49, within, a day or so of practicing this, you're going to be able to go right to what it is, but I want to just show you why it turns out to be. A lot of people know, okay, it turned out to be 7i. But the reason is because if I factor this -49 the same way I kind of would if it was a positive, the two numbers I would pick would be -1 and 49. I wouldn't want to break up 49 because it's a nice perfect square the way it is. But I don't like the negative part. So if you kind of look at it like that, -1 times 49 is the same as -49. But now this is exactly the definition of I, and this is 7. So that's why we end up getting a 7i when we simplify that. So as soon as I see the I in the answer, I know it came from a negative under a square root. So we do really the same kind of thing here. Now you know how to simplify square root of 12. Okay, if it were square root of 12, you would have told me 4 and 3. So if I'm going to get a -12 in there, it's really like -1 times 4 times 3. That would give me a -12. This is I. This is 2. And then that square root of 3 is simplified. The only thing is I guess we're going to switch the order and make this 2i radical 3 rather than I2. That's all. We usually put the I right in front of the radical. If you put it after the radical, sometimes it looks like it's underneath the radical, and it's not. It's kind of replacing the square root of -1. All right, so let's try this one. So we know we want to pull the negative out, and then we just got to think of how, go back to what we did before with 32. Remember, 32 is one of those ones that has two perfect squares that go in, so I want the bigger one. If I use 4 and 8, 8 just has to be broken down again, so instead I'm going to use 16 and 2, just so I don't have to simplify too many times. This is I, this is 4, radical 2 is radical 2 in lowest form, so I get a 4i radical 2. Okay, so that's really how we're going to use it. Most of the times we're just going to use it when it comes up when I use quadratic formula, when I'm getting non-real solutions. Okay, so on the next on the back of this handout, the next page, I'm just going to go through a couple more operations using I. Okay, so take a minute and just kind of jot down what I have in here. I have a definition of a complex number. It's one that can be written in the form a plus bi. Okay, and what you really want to remember in here is that a is the real part, meaning it's not attached to an I, so that's the real part of that. And b is the imaginary part, and that just means that's the part that's attached to the I. So I'm just going through a couple examples of different operations that we can end up doing using I. I, once it's in something, once it's in an expression, it really doesn't act any differently than X. It's just a matter of sometimes I have to simplify and write something in terms of I and then simplify. So let's say, for example, if I want to add square root of negative 8 and square root of negative 50. Okay, so first thing, I have to write these both in terms of I, meaning I have to go back to the skills I know before and simplify square root of 8 and square root of 50. Okay, so if square root of 8 is 2 square root of 2, then square root of negative 8 is going to be 2i square root of 2. Okay, it's the only difference is going to have an I in it to show that I took that negative out from under the radical. And then this one, 50 can be broken up into 25 and 2, right? So 50 can be written as 25 and 2. So this will become 5i radical 2. And then I go back to stuff that, we did back in chapter 1 and how do I add like radicals. And I add like radicals just by adding, this is 2i radical 2 plus 5 more of the same thing. So I get 7i radical 2. So notice nowhere in there, in that problem, did I get an I squared. Because if I add I and another I just get some more i's, just like with X. Okay? So I won't end up using anything with I squared until I get to multiplication. So let's come down to the next one down. And let's look at how to multiply using this. All right, again, this comes back to stuff that we already know in that how do I multiply 5 plus 2i times itself, right? I can't just square each piece. I have to actually distribute it all out. So for the first part of this, it wouldn't matter to me if that was an I or an X. Okay, so I'm just going to distribute out and get 25 plus 10i plus 10i plus 4i squared. Okay, 2i times 2i is 4i squared. So let's see what we get next. So I get 25 plus 20i. Okay, now here's our definition of I squared. If I squared is defined to be negative 1, then there's a better way to write this. If I can write it in terms of real numbers, I'm going to. So if this part right there is negative 1, then that back number really is minus 4, because it's 4 times negative 1. So that back part really became part of my real number, and I can combine it with the 25. And I end up getting a 21 plus 20i. So anytime I'm multiplying, each part has an I, that will happen where I use my definition of I squared. Okay, and then the last little thing we're going to do here is something, again, we've done with radicals, but now we're going to do them with I, which if you're working with I, you are working with a radical, really. So this comes back to stuff we did when we simplified radicals. We said we can't leave a radical, okay, in the denominator, right? Let me just jot that down. So we can't leave a radical. Remember that from before? Okay, so we have to kind of work to get that radical out of the denominator. All right, so when we had a radical near, remember we multiplied by the conjugate of the bottom. Okay, so the conjugate of that bottom would be 5 minus I, and I had to do both to the top and the bottom, so I haven't actually changed the fraction, I'm just rewriting it. And now I just have to multiply out everything. So I'm going to start with the bottom. So I'll end up with 25. I'll get a minus 5i and a plus 5i. Remember, that's supposed to happen. And then in the back, I have a minus I squared. Okay, up top, so let me just actually finish the bottom there. So let's see here. This would drop. Now this back really would become minus I squared if this part is negative 1 that really becomes plus 1. So on the bottom there, I really have 25 plus 1. So you see, I did get rid of my radical, that was my whole point for multiplying by the conjugate. So let's go see what we have up top. We'll have 10 for my first, minus 2i, minus 5i, plus I squared for that one, because of those signs. So then let's see, I end up with, okay, so let's do this. This part right here is negative 1. So it will combine with the 10, and I'll end up with 9. Oops. I'll end up with 9 there, because 10 minus 1, minus 7i. Okay, so the only other thing I would do, I got rid of the radical in the bottom, so that part's good. I just look for at the 9, the 7, and 26, all the numbers, the coefficients, and I just see if I can reduce it, you know, like the way I would reduce any fraction. But nothing goes into all 3 of those, so that's in simplest form. Okay, so what I want you to do is I want you to go through these examples on the right side and try to do them on your own. Okay, and that will be part of the stuff that I check, that you've completed the videos and completed those examples right there, just kind of following the ones that we did on the other side. Okay, check on Blackboard. You'll see exactly what sections are due for my open math, and I will see you guys not for an entire week, so have a great long weekend. Bye.